Welcome back to Calc AB 4.5, example 11. This would be finishing up 4.5. So, me and my shadow, suppose a 6 feet tall person is 10 feet away from a 10 feet tall lamppost. The person is moving away at a rate of 3 feet per second. All right. So, we're given some information. Now, a couple of things here. They already gave us the picture, which is kind of nice. So, one of the things we have to do first is pretty much find what the given is, right? So, the given information. And in this case, we're pretty much given the rates at which the person is walking away from the lamppost, right? So, and in this case, that would be the distance from here to here. So that's the 10 feet. And the person is walking in that direction at 3 feet per second. All right. And in this case, let's call this D. All right. So that would be the given is dd over dt for distance equals 3 feet per second. All right. And then in this case, what we need to find is how fast the length of the shadow is changing. And the length of the shadow here is given by x, right? So this is x right here. So in this case, we need to find dx over dt. So how fast is that changing, right? It's also a rate as well. So now, and in this case, we have, in order for us to figure out the equation, we're going to be using similar triangles, right? So again, this person is 6 feet tall, should be right there. And if you notice, I have a similar triangle here, here. It has this angle in common, right? Between both triangles. And then therefore, right, because all angles inside a triangle add up to 180 degrees, those two angles also have to be the same. So in this case, this is again, you can say it's angle-angle similarity, which allows us to pretty much set up a ratio, right? If we compare the side lengths. So for example, the length of the tall person, right? And then the 10 feet tall lamppost. All right. So in this case, let's set it up that way. So the equation we're going to be using is going to be pretty much, so again, the height of the person compared to the height of the lamppost is 6 over 10. And that's going to be equal to pretty much the length of the shadow, right? The length of the shadow, which is x, over the length of the total part of the big triangle, which would be x plus 10. Or in this case, let's leave it as d plus x, right? Okay. So now we can simplify this a little bit more, right? We can just reduce the fraction right here. That's going to be 3 over 5. So we're going to solve that. So it's 3 over 5 equals x over d plus x. Cross multiply, you're going to get 3 times d plus x equals 5x, right? So the Shuri property, so 3d plus 3x, just to make it a little bit simpler, equals 5x. So we subtract 3x from both sides and we end up with 3d equals 2x. Take the root of both sides, and we have now 3 times dd over dt equals 2 times dx over dt. And then here, substitute, so 3 times 3, right? That's the given, 3 feet per second equals 2 times dx dt. So that's going to be 9 equals 2 times dx dt. Divide both sides again by 2, and we end up by 9 over 2 equals dx over dt. So we can say that the length of the shadow is growing at a rate of 9 over 2 feet per second. All right. Make sure you always include the unit for this. So let's look at part B now. So we have, at what rate is the tip of the shadow changing? So in this case, we want to know how fast is dx over plus d over dt changing. So we want to know how fast is this entire shadow changing, all right? So we need to find dx over dt plus dd over dt. Okay, so that's what we need to find. We need to find how fast this is moving forward. And in order for us to do that, we have to figure out how fast this is changing, which we already know. We also know how fast this is changing, right? So all we have to do is just pretty much a substitution because the first one we know is moving at 9 over 2 feet per second. And then the second one is moving at 3 feet per second. And that would pretty much just give us 15 over 2, right? Feet per second. And in this case, we can say that the tip of the shadow is moving away from the lamppost. Might be missing a P in there. I don't know. Throw it in. At a rate of 15 over 2 feet per second.